So it's lucky video number 13, and it's certainly lucky for you because there's no quiz at the end. But this is going to help you work with the data for your project so you can do your write-up. All right, so the big takeaway of the NHAMCS data set is, well, not the big takeaway, but when you're actually wrangling with the data set, you have to always remember that it is weighted data. So what is weighted data? It's used by other data sets, including the NHANES. Basically, a complex analysis is made prior to the release, and each row of data actually represents multiple patient visits. And the NHAMCS 2018, the minimum was 73, the max was over 28,000. And basically what it does is it statistically represents the entire United States population. It's weighing the data allows the people who put it together to do a targeted audit of the universe of data, which fancy speak, what that means is they don't have to actually abstract every ER visit, which was 150 million visits in 2019 per the data set. They just have to pick about 20,000 visits, and then they can extrapolate from there how all ER visits look like, the large majority of them. The 2018 data set, about 20,000 rows, statistically represent about 130 million visits. It keeps the cost of collecting data small, and it making all data available could potentially identify patients. But there's some problems with it, obviously. It is harder to work with. You don't count the rows, but you add their weight. And we'll get into that. And if you're looking for descriptive statistics of things like heart rate, that requires complex formulas, which include the weight in there. Rare conditions either are completely missed or totally misrepresented. If you wanted to do a study on hereditary angioedema, most likely you're probably not going to find anybody. But if one accidentally slipped into the visits that was 28,000, that doesn't mean that 28,000 people visited for hereditary angioedema. That's just a quirk of statistics. So NAMCS has weighted data guidelines. So estimates should be based on a sample of greater than 30 rows. Oh, sorry. So estimates based on a sample of less than 30 rows are unreliable and shouldn't be reported. Estimates with a relative standard of error greater than 30% are unreliable and should not be reported. And what the relative standard error is basically if it's 30% of the reported average, then it's too high. It's too volatile, essentially. Items with a non-response rate of greater than 30% are unreliable and should not be analyzed, and you should round visits to the nearest 1,000. And it's the NAMCS rule of three. It's got to be greater than 30 rows, less than 30% standard error, less than 30% non-response rate, and 3 place settings. All right. Now, very quickly, I've made this recording that's going to come up in Excel because I think a lot of people have access to Excel and I'm more familiar with it. If you do not have access to Excel, you can do this in an open office alternative called OpenOffice, openoffice.org. I'm going to leave a link in the show notes. It can open Excel files. It's a little bit wonkier to work with, but it should, be fine. If you download OpenOffice and are struggling with it, don't hesitate to email me. I will help you through it. Okay. All right, moving on to a sample of how to use the Excel spreadsheet. The link is down at the bottom in the show notes. But when I give you data, it's going to look something like this. and you cannot start just running averages and standard deviations using built-in Excel spreadsheets of this. Let me just tell you what's going on with this sample data. So this is heart rate, pulse, and pay type is the insurance. And way over here is for the purposes of this lecture, is the most important value. I'm always going to start it with pat weight, which is the patient weight. That means this visit where the pulse was 95 and the insurance status was unknown represents about 4,700 visits in the system. So what you're going to do is you're going to take it and then you're going to open the other weighted stats spreadsheet that I've given to you. And it's kind of confusing what you do, so that's why this walkthrough exists. So we're going to start with linear statistics, and this is going to be used for the heart rate. So we're going to copy the patient weight and put it where it says patient weight. And it's going to take a while to crunch because I've made it so it's possible that there can have up to 1 million rows because there are about 750,000 rows of data in all of NHAMCS so far. So I went to the max here, but that means crunching sometimes takes a while. So then you take the measure, which, because we're doing linear stats, is the linear number, the pulse. So we're going to copy that, and we're going to paste it over measure. And now it's going to start crunching. Now, there's one more thing. You see this highlighted in red? The statistics below won't work unless you have sorted the values in column B by lowest to highest values. So that's what we're going to do right now. We're going to select this data. We're going to go to data over here, and we're going to click the sort button. And we're going to make sure it says sort pulse by smallest to largest. And because I've been playing around with this, it's already pre-selected. Pulse, smallest to largest. Okay. That really, there it is, 66. It's going to take a while to calculate. Almost done. All right, good. So you're going to see way over here, this is doing supplementary calculations. You don't have to worry about that, but I've left it visible for you just in case you're curious how this all works. But this is where you're going to find everything of importance. So this is from the 2019 data set, by the way. So we're looking at about 140 million visits. The average heart rate was 92. Standard deviation 23. The standard error was very small because it's 140 million visits. So the CI 95 lower and higher are like so close together, it doesn't even matter. But if you're going to be looking at 100,000 visits because you're really narrowing it down, then it's going to be a broader confidence interval. It shows you the minimum and the maximum, 0 and 221. And down here, this is what you needed to sort it for. This is the rankings. Here's the 10th percentile. Here I actually did the lower whisker and the upper whisker of the box plot, which you see over here. And then you got the first quartile, the median, the third quartile, the 90th percentile. And here, if you, for whatever reason, you need a custom percentile, you can type that in and watch the hamsters go. And so here, the 45th percentile is 82. And so it will come up with a box plot, just because box plots are somewhat hard in Excel, but all the rest of this stuff you can do, you can compare once you move it to a different spreadsheet. All right, that's it for linear stats. Let's go to categorical stats. This one works a little bit easier, I think. So we're going to go to our data. Once again, we're going to get patient weight. And we're going to get, this time our measure is the pay type. This is, unknown. Is it Medicaid? Is it Medicare? Is it private insurance? Is it self-pay? So those are the categories. That's what we mean by categorical. So we're going to paste that here. And then what you're going to do is right button click on this table here and say refresh. Uh-oh, something happened. All right, if that happens to you, just move pay type here. And now suddenly you've got, yeah, and if for whatever reason this didn't come here, you would just move that there. But yeah, you would move this so it says sum of patient weight. Drag and drop from here to there, drag and drop the measure that you are measuring over to rows, and now it's adding the patient weight as all our sources of payment are blank, Medicaid, Medicare, and now you can copy and paste this data into another spreadsheet and work with it from there. So I hope that helps. Once again, if you have any questions, don't hesitate to email me if you're taking the course for credit. If you aren't taking the course for credit, don't you can just put a comment down there in the comment section, and haha, there's no quiz. How marvelous.